Okay, now let's proceed with Roman figure 2. So my angle of interest with the first one, sine alpha. So the angle of interest here is alpha. So I have to go and stand at alpha and determine what the opposite is and what the hypotenuse is, because sine is opposite of a hypotenuse. Now remember, hypotenuse will always face 90 degrees and it's always the longest side. So the opposite, if I'm standing here, it's 6, and my hypotenuse, it's 2 square root of 34. So I'll need to punch this in a calculator just to simplify it. Let's quickly do that. So 6 over 2 square root of 34. This gives us an answer of 3 square root of 34 over 34. So this is 3 square root of 34 over 34. Now let's find an answer for sine theta. So with sine theta, the angle of interest is theta. I will have to go and stand at theta. So theta is here. So my opposite will be 10 and my hypotenuse will be 2 square root of 34. So this will be 10 over 2 square root of 34. So just punch that in a calculator and then get the value. Let me just delete 6 and put 10 here, and then the answer is 5 square root of 34 over 34. So 5 root 34 over 34. Now we find sine squared alpha plus cos squared alpha. Now, when it comes to the squared ones, I think I should do it separately so that we can all see what will basically happen here. So if we're speaking of sine squared alpha plus cos squared alpha, this sine squared basically means, so if you've got sine squared alpha, this is the same as sine alpha to the power 2. So you'll find the value of sine alpha and then you write it as a fraction and then you raise that fraction to the power of 2. That's what it means. Or you can just say it's the same as sine alpha times sine alpha. So sine alpha, we got it here. It was 6 over 2 square root of 34. So this has to be raised to the power of 2 plus cos alpha, I have to raise it to the power of 2. So cos alpha, if I'm standing here, my adjacent is 10 and my hypotenuse is 2 square root of 34. So I'll just punch this in a calculator and see what my answer will be. So let's quickly do that. 6 over 2 square root of 34, and then I square everything, plus 10 over 2 square root of 34, then I square everything, and the answer that it gives me, it's 1. Now this is a very special identity. So it's a very special identity. So in maths, under trigonometry, so sine squared plus cos squared will always have to give you 1 if you are evaluating that from the same right angled triangle standing at the same angle that you will be using as an angle of interest. So cot theta, cot, remember it's a reciprocal of tan, and tan says to r, which is opposite over adjacent. So cot will be adjacent over the opposite. So if I'm standing at theta, my adjacent it's 6 and my opposite it's 10. Then cosec alpha, cosec, it's the reciprocal of sine. So sine says so, which is opposite of hypotenuse. So cosec will be hypotenuse over the opposite. So my hypotenuse, if I'm standing at alpha, hypotenuse, it's 2 square root of 34 over the opposite, which is 6. And the answer in this case, so if I've got 2 square root of 34 over 6, the answer becomes square root of 34 over 3. Now this one simplifies to 3 over 5, the one for cot theta. So tan alpha tan, if I'm standing at alpha, tan alpha will be the tan definition, it's opposite of adjacent. So tan alpha, it's opposite, it's 6, adjacent, it's 10, which draws back to 3 over 5. And then sec squared alpha. Sec is a reciprocal for cos. So cos says it's adjacent over hypotenuse. So sec squared will be the hypotenuse over the adjacent, and then you raise it to the power of 2. So the hypotenuse in this case, it's 2 square root of 34 over the adjacent side. So if I'm standing at alpha, the adjacent side, it's 10, and then I raise that to the power of 2, then I get the solution. So let's just put it here. So if I've got 2 square root of 34 over 10, then I raise it to the power of 2, I get 34 over 25. So that's the solution for sec squared alpha. And then 2 sine alpha cos alpha, let me just write it down here. So 2 sine alpha cos alpha is the same as 2 times. Now sine alpha, I think we got sine alpha somewhere there, which was 6 over 2 square root of 34 times the cos alpha. Cos alpha, if I'm standing here, cos, it's car adjacent over hypotenuse, so it will be 10 over 2 square root of 34, and then you just punch that in a calculator, and then you get the solution. So let's quickly do that. So it's 2 times 6 over 2 square root of 34 times 10 over 2 square root of 34, and then our answer becomes 15 over 17. So this is 15 numerator, 17 denominator. So sec alpha times cosec alpha times tan alpha. I think we got sec somewhere. Sec alpha. Yes, so sec alpha was 2. So let me just write it down here. It was 2 square root of 34. So let's say sec alpha times cosec alpha times tan alpha. So sec was 2 square root of 34 over 10. So multiplied by cosec alpha, we got cosec alpha here. It was 2 square root of 34 over 6. And then times tan alpha was 6 over 10. So sec alpha, it's 2 square root of 34 over 10. Cosec alpha, it's 2 square root of 34 over 6. And then tan alpha, it's 6 over 10. So you just punch this in a calculator, and then we get a solution. So it's 2 square root of 34 over 10. I made 37 there. Let me just fix it quickly. So 2 square root of 34 over 10 times 2 square root of 34 over 6 times 6 over 10. And then we get our solution there, which is 34 over 25. So this is 34 over 25. So this are the solutions that you were supposed to write, and I hope that this was clear and you were able to understand everything. And I believe that you will continue to practice. So I will upload some of the questions that we have to practice on in order for us to stress the understanding of this before we move to more complex questions. And I hope that you keep on practicing. So any questions based on this, you can just hit me on my inbox for WhatsApp, but the videos will also be available on YouTube. For those who will still want them, you can also download them and then just use the videos to practice each and every time, and then just to revise the knowledge or some of the things that you have forgotten. I wish you all the best in your studies, and please stay safe, stay home during this COVID-19 pandemic. And I hope that at home you will be studying like never before. Thank you.